Hi, and I hope you're all well. Today we're going to revise volume and surface area, which is something we were getting really good at before lockdown. So be a good thing to revise today. First of all, what is volume and what is surface area? Well, let's take this cube. And remember in class I had lots of multi-link cubes, and I was getting you to build shapes, and we can imagine one of those multi-link cubes as a 1 centimeter cube. So remember volume, we're asking how many of these 1 centimeter cubes can we fit into our shape. So in this case it is 1 centimeter cube, so my volume of this would be 1. Surface area, I'm looking at the area of all of these faces. So if I take the area of this face, then that's 1 centimetre squared, and I know there's 1, 2, 3 that I can see, but there's also one round the back, one to the side and one underneath. So actually in total there's 6, so my area would be 6 centimetres squared, remember, because I'm saying how many of these square centimetres, the squares on the outside, can I fit around my shape. Right, let's have a look at an example. This one. So, first of all, I've mentioned what volume is. It's how many of these centimeter cubes, how many of these can we fit in my shape? And this one it's got your cubes out for you, so you could count it. But remember, we're not always going to be given the how many cubes are in it. We might just be given the dimensions. So here, this is a 1 by 4 by 3 cuboid. And just so to work this out, as I said, we could count all these cubes, but something else we can do, if we're not given how many cubes there are and we're just given the dimensions, is do the length times the width times the height. Or another way to think of it is, remember a prism, volume of a prism is area of cross section times by length. So in this case, the cross section is this rectangle here. So the cross section of this would be, the area of it would be 4 times 1. Then my length is times by 3. So I can do, let's just get rid of those. To work out my volume, 4 times 1 times 3, which is 12, what would it be, centimetres cubed. The formula for any cuboid then is length times width times height. Gets you the volume of a cuboid. Right, surface area. Maybe you just want to have a go at it before I go through it, so you can pause the video and then I'll go through it. Make sure you get both of these down in your book. Right, surface area. So I need the area of all my surfaces. So let's well, this is just a reminder of how we laid it out in class. We'd start off by calling it front and back. So let's look at this front face here, and we actually worked out the area. So this is my front face. My front face would be 4 times 1, which is 4, and then I need to times it by 2. Why do we need to times it by 2? Because we've got the back as well. So my front and back are 8 centimetres cubed. Now I need to do right and left, and you don't necessarily need to do it in this order. You could have started with right and left. So my right face, let's just highlight it. My right is here, so my left is just, it's like that side where I've just made a mark there. So my right would be 3 times 1, because that's what the area of that face is, which is 3. Then times it by 2. Why do we times it by 2? Because we've got a right and a left that are the same. Right, finally, top and bottom. Let's just mark on where the top face is like I did before. So my top face is this red one here that I'm highlighting in yellow. And then my bottom would be underneath it where I just made a mark there. So the top face is, well, it's a rectangle of 4 times 3, which is 12. And then I've got to times that by 2 because there's a top and the bottom. So that's 24 centimeters squared. Right, what do I need to do with all of these now? Well, I'm finding the total surface area, so I need to add those all together, which gets me 38 centimeters squared. So if we counted all of these squares, then we would in total count 38 centimeters squared. You wouldn't get that just from the ones that you see, because remember, you can't see the ones around the back and the left and the bottom. Right, so that's for a cuboid. Let's go on to a triangular prism. Remember, our volume of the prism is area of cross section times length. If you didn't get that down last time, make sure you've got it down. Remember, my cross section is, if I cut through that shape, then the cross section will be the same throughout that shape. So my cross section is this triangle at the front here, because wherever I cut through that, say I cut through it here, then I would still find that I have a triangle in the shape, or if I cut through it here, I would still have a triangle as my front and back. So let's start off then with volume. And again, maybe you want to have a go at it before I do, so feel free to pause the video and have a go at it, and then just you can mark it based on what I do now. So volume, we need the area of that front face. It's a triangle, so the area of that is equal to base times height. Well, base is 4, height is 3. And then because it's a triangle is half a rectangle, I need to divide that by 2. So 4 times 3 is 12, half that is 6. So the area of that face is 6 centimeters squared. I then need to times it by length. My length here is going all the way along, so my length is 8. So I need to do 6 times 8, which is 6 times 4 is 24, so it's 48 centimeters cubed. So I'm saying I could fill that shape with 48 little centimeter cubed. Remember my multi-link cubes at school? I could fill, if I'd need 48 cubes to make that shape. I know I couldn't exactly make that shape because they're cubes and I've got a slanted face there, but it's just to give you an idea of what volume actually means we're working out. Right, surface area, and we were really good at this before lockdown, so hopefully it's just a bit of a reminder to you. Surface area, thinking how can we, the sort of words that are associated with surface area are covering the shape, or if you wrapped the shape in something, or if you're thinking about like the packaging, so the amount of paper that would need to be you'd need to cover it again. So I'm going to do it similar to last time, front and back. Well, my front, I've actually already worked out the front area here. It's 4 times 3 over 2, which is 6, and then I need to times it by 2 because there's a front and a back. So that will get me 12 centimeters squared. I've got my front and back. Let's do this face here, which sort of looks like your front, but let's just call it right, because we've got our front and back in, or our front in yellow, so we'll call that red face the right side. So the right is a rectangle of 8 by 3, which is 24. Now I need to do, so I'll just highlight that in red so you know where it comes from, or what shape it's referring to. Right, the bottom is, let's do it in a different colour. The bottom is this face here. So if I look at my dimensions of that triangle, which is, I think, the trickiest thing, is that, well, what are those lengths? So that's 8, and this length is 4. So it's a rectangle of 8 by 4. So to work out the area, I just need to do 8 times 4, which is 32. Again, let's just highlight that for you. Okay, final side is my rectangle that's a slope. So remember, a triangular prism is made up of 2 triangles and 3 rectangles. So you always need to make sure, have I got my 2 triangles, have I got my 3 rectangles? Well, your slope is this face here. So what are those dimensions? Well, I know that this is 5. Well, what's this length here? I know that's 8 from my previous, because it says it on the bottom there. So there we go. So that slope is 8 times 5, which is 40 centimeters squared, and I think I did that in, green. Yeah. Right, so I've got my 3 rectangles, I've got my front and back 2 triangles. What do I need to do with those? I need to add them all together. And you can use a calculator for this. I just don't have mine to hand. So 4 add 2 is 6, add 2 is 8, 4, 7, 10. So my surface area is 108 centimeters squared. Right. I'll just leave that on the screen. You can pause it on there. Make sure you've got it down in your book. And then if you just want to make any top tips for yourself, think about, well, there's 2 triangles and 3 rectangles on a triangular prism. So that's, you're always looking to have the area of 3 rectangles and 2 triangles. Okay, last one. And I've probably saved the hardest for last. So we've got volume and surface area of a cylinder. So it's similar to my prism formula, because I need to do the area of the cross section times the length. And in this case, my cross section is this circle here. So any circle question, anything to do with circles, I should be thinking right down track. So let's get down DRAC. And again, maybe you want to have a go at it before I go through this. This is just a bit of a revision. And then I think tomorrow I'll set you a maths watch task with some volume and surface area questions. And then the next day, I'm going to do some GCSE questions with you. Right, so diameter, I know that goes through the centre from side to side. My diameter is 16, so my radius is half that, which must be 8. Area is pi r squared. Circumference is pi d. I need the area of the circle. So area equals pi times 8 squared. 8 squared is 64, so I know the area is 64 pi. Now I need to do that area times this length here. I'm just going to get rid of it so it makes surface area easier later. So I need to do, for volume, I need to do 64 pi times, and remember 64 pi, you can just type it into your calculator. I haven't got mine on me, unfortunately. I have to use my phone. 64 pi times pi is 201.061 blah 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 blah. The reason I use 64 pi is because it's more accurate, because I don't have to type in loads of decimal places then. Don't have to do all this dot dot dot. I can just type 64 pi in my calculator, times it by 21, which is 4,222.3 blah blah blah. Let's round it to the nearest whole number, which is 422, and then we don't actually have any dimension, like we don't have any length units there, like centimeters or meters. Let's just call it centimeters. It will always be cubed for volume, because we're asking how many little cubes can we fit in that shape. Right, surface area. Surface area is like, it's like, or it's the same as finding the area of the net of that shape. So remember when I had that GeoGebra file and it would split up this shape. If you want to see that again, just type in GeoGebra surface area cylinder, and you can play around with it yourself. I'll put it in the notes to in the description of this video as well. Well, if I unravelled that, then I'd have a circle on top with a rectangle and a circle on the bottom as well. So I need the area of my two. Surface area equals area of the two circles on either end plus the area of my cylinder. So let's get the area of the two circles first. We've got our DRAC written over here, so I'm just going to use that again. But if it was a separate question, I'd write out DRAC again. So area I know is 64 pi, and then because there's two circles either end, there's one here and one here, I need to times that by 2, which would get me 128 pi. I'm just going to leave it in terms of pi now. So then I need the area of this rectangle here. Well, I know the height is 21. That length there, let's do it in pen. That length there is 21 because it says it in the question here. The length that's harder to see, or we're going to need to do some working out for it, is that length there. But if you look, that length there, it wraps around this circle. So this length here must be the circumference of my circle. So let's just put in, we've worked out the area of the two circles there. So now I'm working out the area of the rectangle. Well, I need to do circumference is equal to pi d. I know my diameter is 16, so that's 16 pi. So this length here is 16 pi. To get the area of the rectangle then, I need to do 16 pi times 21, which obviously you need your calculator for. And for that you get 16 times pi times 21 is 1055.57513 blah 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 blah. Or actually, let's get more accurate. So I could, that is 336 pi. So then my final answer, I can do 336 pi add 128 pi, because this is my two circles, this is my rectangle, which gets me 464 pi. And again, you can just do this in your calculator without having to worry about pi, but you need to do as many decimal places as possible if you're not using it in terms of pi. And 464 times pi is 1457.698 blah 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 blah. Again, let's round it to the nearest whole number, centimeters squared. And that's your final answer. If you need any support with any of those things, so today we've gone through volume and surface area of a cuboid, triangular prism and a cylinder. I'll set you a must watch on this tomorrow, so make sure you understand how to work these things out. If you need any help, just email. Have a great day.